Hey everyone, I'm Kelly, and this is my presentation about binary code. Binary code is a series of zeros and ones that represents digital data. And it can represent numbers, it can represent sounds, letters, colors for images, just about anything you can think of, it can be represented by binary digits. And binary digits convey their information to computers and other devices in a number of ways, such as light and dark spots on disks, or tones over phone lines, different voltages, or the orientation of magnetic particles on a hard disk. And in this video, I'm going to show you how to convert binary code to decimal and decimal to binary code. So, I'm going to start by doing the easier one, which is converting binary code to decimal. And I'm going to convert the number 101001 to decimal. And the way it works is just like with the places in decimal code. So, for example, if in decimal you were writing 12,825, you have the ones place, the tens place, the 100s place, the 1000s place, and the 10,000s place. And it just keeps going up by powers of 10. So it's the same thing with binary code, only in binary code it's by powers of 2. So you have the 1's place, the 2's place, the 4's place, the 8's place, the 16's place, the 32's place, and the 64's place. And after that, it's pretty easy. So you've got 164, you've got 116, you've got a 4, and you've got a 1. So you just add all of those up. And 4 and 6 and 4 and 1, that's 15. And 6 plus 2 is 8. So the number ends up being 85. Converting decimal to binary is a little harder, but not impossible. So I'm going to convert the number 51, which is my birth date, the 21st, plus 30. So I'm going to go ahead and put the 64's place, and the 32's place, the 16's place, the 8's place, the 4's place, the 2's place, and the 1's place. And this can keep, the powers can keep going on by powers of 2, as far as you can think of going. So the first thing you have to do is you have to figure out which is the biggest number that goes into 51. And it doesn't have to go in evenly, like it does with some math. But 64 doesn't go into 51, so we can get rid of that. 32 does, though, so we can change that 0 to a 1. There's no such number as 2 in the binary digits. And you have to figure out what's left over. So 51 minus 32 is 19. Well, 16 goes into 19, so you can change that to a 1. And you've got 3 left over. Neither 8 nor 4 goes into 3, but 2 does. And you end up with 1 left over. So you got a 1. And that's how that works. It's really pretty simple once you've practiced it some. But I think doing it with an actual computer is probably a bit harder. And I think that's all.